Hey guys, welcome to day 7, mixed surface area practice. Our math meme of the day is, I'm still confused as to why I need to put my cake in the oven at 120 degrees. Seems like an odd angle to have to put that at. Just thought that one was kind of funny. Hopefully you guys are enjoying being able to cook things if you like to cook. I've heard some of you guys have been baking. Hopefully you guys are helping your families out with some of the cooking responsibilities, right? Learning some good life skills. So our day 7 is just some practice, right? So yesterday you had practice and you took a quiz just for me to be able to give you feedback. So today is just a little bit more practice. Normally you would be working on these with your group. But there's, let's see, 2, 4, I think there's like 6 problems. So I'm going to go through these and work them out with you guys. Feel free to go at your own pace. So for the first one, we have a half cylinder on top of a rectangular prism. So for my rectangle, I know I have 2 of those, right? So I'm going to do like my front and back, both 8 by 10. So that means it's 160 inches squared altogether. I know I've got my sides, which is 6 and 8 tall, right? 8 is your height of your prism. So 48, and if I double that, right, I'll just make my little times 2 note, that's going to be 96 inches squared. And then I only have a bottom, right? I just have one bottom, because my top is covered up by the cylinder. That's going to be 10 by 6 or 60. And then for my cylinder, if you're creative about this, you can make some less work for yourself. So what you could do is treat this and this as one circle, right? It's 2 half circles. For the radius, this across is 6 inches. So radius is half of that, or 3. I'm going to do pi times radius of 3 squared. So that's going to be 9 pi inches squared. And then the last thing I need to find is the surface area of the outside. And that's going to be a rectangle. Let's see, our rectangle has 10 given as like the height of the rectangle. And then this is going to be your circumference, 2 pi r, but cut in half, because it's only half of a cylinder. So the 2's are going to cancel out. So it's really just going to be pi times radius, and our radius in this case is 3. So 3 pi. The area of that's going to be 3 pi times 10, or 30 pi. Okay, so I'm going to add all those together. I've got 39 pi plus, it looks like, let's see, 96, 160, and 60. So 316 inches squared. If you wanted the decimal answer, if you add those together, you should get 438.52 inches squared approximately. Okay, let's see. Oh, this one's a really interesting shape. We have the total surface area of a regular octahedron, which is 8 faces that are all congruent equilateral triangles. Now each edge, we're told, is 6. So basically we just have 8 triangles, right? And they're all the same. These are 6, these are 6, bottom is 6. I need the height of this triangle, right? Because I need base times height. This is going to be 3. Right angle, remember if it's equilateral, all equal sides, angles are 60 degrees, and those are all equal. So you're going to have a 30, 60, 90 triangle. If your base is 3, because notice it's half of the whole base, right, you're going to do 3 times root 3 to get your height, so it's going to be 3 root 3. So your area of your triangle is going to be base times height cut in half. Your full base is going to be 6 times your height of 3 root 3, divided by 2. 6 times 3 is going to be 18 root 3. Cut in half, you can just focus on what 18 cut in half is going to be. And that was not the highlighter like I thought it was. Come on, highlighter. There we go. 18 cut in half is going to be 9, so it's going to be 9 root 3. But notice that was just the area of one triangle. If we want 8 of them, we're going to do 8 times 9 root 3. And then that's going to give us 72. Sorry, guys. 72 root 3. I don't think they gave us units, so I'm just going to say units squared. Okay. So that one's a little bit interesting, right? It's got some more going on. Notice I'm leaving my answer in terms of root 3. Let's see what we have next. And we're getting into some more interesting shapes. You can see, right, as we have practiced more, we're ready for some more complex surface area problems. This next one is a sphere is inscribed in a cube. What that means is this sphere is touching like at just the edges of the cube, so it's like it just fits into the box. The surface area of the cube is 64 meters squared. Okay, so what does that tell me? There are 1, 2, 3, 4, 5, 6 squares that are adding to 64. If I cut that by 6, that means each square is going to be equal to 10.6 repeating units squared. Which is not the nicest amount, right? So let's think about how could we find the surface area of the sphere. We are looking for, of our sphere, if I look at it kind of head on, right, your sphere is kind of all the way across. So if I know how far across my square is, I could get my radius, and I need the radius because my surface area of my cube is 4 pi r squared. So if we use our square and figure out the side length of the square, that would correspond to the diameter. So the side length of your square, we can figure that out by doing the square root, 10.6 repeating. So I've got 10.6 on my calculator. I'm actually going to pull it up on the screen just to show you guys what I want you guys to type in. So I'm going to do my 64 divided by 4 one more, or divided by 6, excuse me. And then I'm going to do second square root, second answer, which is the negative sign. And that's going to pull the exact full answer for me. Another option you could do is the square root of 64 divided by 6. Gets the same job done. And then that's going to be our side length, right? We want our radius. And our radius is going to be half of that, so I'm going to divide that by 2. Just going to make a note, we got 3.26, I believe, or 27 if I round up. Okay, and then radius equals 3.27 cut in half, which is about 1.63. So my surface area is going to be 4 times pi times 1.63 squared. This is a good example of one where you would want to round. So that's going to be my radius squared. I'm going to do that times 4. So it looks like it's 10.6 repeating pi meters squared. And this one's kind of a nice example of if you use the exact answer on your calculator the full time, notice you get something that is repeating, right, 10 2/3. So if you are careful and use the full exact answer in your calculator, you should get 10 2/3. Okay, this one's actually, I think, a little bit easier than the last one that we did, which is kind of funny, the order of that. This one just asks us to find the surface area of our hemisphere. So I can easily find the area of the circle, right? My area of my circle is pi times radius at 15 squared. It's going to be 225 pi inches squared. Okay, from here, I need to find the outside bit here. That's going to be my surface area of a sphere, which is 4 pi r squared, but I want half of that. Right, because remember, the surface area of a sphere is just the outside because I've kind of sliced it down the middle. So this one's a little different. So that means it's going to be 2 pi r squared. 2 times pi times radius of 15 squared. It's going to be 2 times 225 pi. So that's going to be 450 pi inches squared. And we have to add that to our previous answer, right? So that looks like it's going to be 675 pi inches squared. Notice leaving your answer in terms of pi, right, is making it a lot easier than rounding. Okay, so that one's not too bad. That was actually, I would say like difficulty-wise, this would be like a core problem. This one might be more of a mixed level. First one was definitely a core. I'd say number 2 was mixed because we had to use our 30, 60, 90. So it's kind of gone core, mixed, mixed, core. We got 2 more. And I believe that says 20 meters. I'm just going to double check my document just to make sure. Okay, so I did double check and that should be at 20 meters. It just, the text box got a little covered up. So let's see, we want the surface area of our square pyramid. I could definitely get my area of my square bottom, right? It's 42 by 42 because the sides are equal. So my area is going to be 42 times 42, which comes out to 1,764 meters squared. And then the tricky part is my triangles, right? If I kind of draw out what my triangle looks like. I know that this side is 42 because the bottom of my pyramid is a square, but I'm missing the height, right? Now, if I draw the height in to this picture, I'm going to just draw that height of that triangle, right? It makes a right angle with the base. What you can see is that if you connect that to the altitude of the pyramid, the altitude, you can kind of think of that altitude of the pyramid. You can kind of think of it as the pyramid was a tent. The altitude is just the pole that's holding it up. So it's the height of the pyramid. It's not the height of the triangle necessarily. So if I draw in this triangle, this is 20, and we're looking for this, I'll call that H. Now the trick to get the bottom side here is that that's halfway across the square, because if you were to kind of draw the rest, that would be 42. So this is going to be 21 meters because it's half of that. It's halfway across. So if we use Pythagorean theorem, 20 squared plus 21 squared equals H squared. 21 squared is approximately 441. Add that to 400, we're going to get 841 equals H squared. If I square root that, H equals the square root of 841, and H is exactly equal to 29. So my height of my triangle is going to be 29, which means my area of my triangle is 42 base times height 29 divided by 2. I'm going to quickly calculate that on my calculator. Looks like it's 609. And then remember that there are 4 triangles, so I'm going to do times 4. I just make a little note. It comes out to 2,436 meters squared. To finalize our answer, we're going to have to add those two amounts together. So I'm going to add that to 1,764. My total is a nice number of 4,200 meters squared. Okay. So I would say this one would be a mixed level. And the reason why I would call this a mixed is because of this concept right here of how we had to solve for height using the context of our picture. Okay, last one. I like to think of this one as kind of like an hourglass. Right, you can picture the sand in the hourglass. And this one is made up of 2 cones, and we want the total surface area. So it looks like the 2 of them put together is 80, right? Which means that this one is 40 inches, and this one is 40 inches. So I'm going to just draw 1 cone, looks like, just to get a sense. This is 9. So let's see. For my cone, I know that the area of the bottom is a circle. And there are 2 of them, right, because there's a top and a bottom cone. My radius is 9, so area is going to be pi times 9 squared, which is 81 pi. And I'm going to do times 2 because there are 2 circles. It's going to be 162 pi. My units are inches squared. So I've satisfied the circles, right? I'm kind of shading in those to show where we've been. Now we need to get the other bits, right? This outside, this outside. And remember, those look like a Pac-Man shape if you were to slice it down. Right, you can kind of picture this Pac-Man shape that I've drawn if you connect the 2 slits. And if you were to, like, reattach it and tape it together, it would pop up like a cone. So let's see. To get